Hello, it's Scott Manley here with part 6 of my beginner's walkthrough. We are in orbit. So now, you see the blue orbit, that's the one we've got. The yellow one was the one we predicted. They're pretty close. We are in orbit. The important thing after being in orbit is you want to make sure that your periaps is above 70. And your apoaps, well, if your periaps is above 70, then your apoaps is going to be above that. You don't need to get a perfectly circular orbit. You just need to make sure that you are in a stable orbit that does not enter the atmosphere. So actually, let's just do time acceleration again. So again, I can time accelerate around, and we can watch the sunrise from here. It only limits you to 50 times time acceleration, but you can see us moving around the planet, and there comes the sun. Okay, we're in space, let's do the science. Observe the materials bay for, well, look at this, 25 science from the materials bay. Great, we're going to keep that. Have we got mystery goo from space? Yes, we've got mystery goo from space. We probably didn't need to bring that, but we'll keep it anyway. Keep data. Temperature from space. Have we measured the temperature of space? No, we haven't. And we do have a crew report already, so there's no point in that, so let's just reset it. Now, I would suggest that before we go on EVA that you turn it side on, because coming with the door above you, it can sometimes be kind of hard. Jebediah's going to get out again. And first thing we're going to do, we've already done an EVA report, but you might be finding that you're over a different location. So now I'm getting an EVA report over the water. Great, store that. And before we return, we want to recover all our science data. So press space to let go, then press R to bring up your control system. And now the QWASD lets you fly around, so you can do A and D do left and right, W and S is back and forwards, and Shift moves you up and Control moves you down. So you want to try and maneuver close to this. You have a limited amount of fuel, but it's not so limited that you should be concerned. Move yourself close to it, and once you're really close, you can right click and of course collect the data. And you can also grab other items if you like, but that's the main one you want. You want to collect that. I'm going to try and collect the data from this. Excellent. So we can get that. And F to grab. Let's just store the data one more time. And let's do an EVA report again. Now we've already got the water. Okay, let's board. And it tells us that we can't collect that data again. Okay, so we are in orbit. We can stay in orbit as long as we like, but eventually we're going to have to come back. And I'm going to try and come back over these deserts, right? So to come back over the deserts, what we're going to do is around here, we're going to fire our engines. And instead of going faster, we're going to go slower, right? So we're going to fire our engines backwards. And if I drag this, you can see it makes this green or this yellow orbit. And that's actually pretty good. Let's drop, for this very first descent, we're going to put our periaps at about 35 kilometers. And that should actually be pretty good. We'll fly across and hopefully land on the desert. But we're going to have to go all the way around to there. Before we go around to there, let's actually try and collect the data from over the desert. The EVA data from over the desert. Like, we just fly forward using the time acceleration. And now we're here. We are over the desert biome. And indeed, Jebediah can go EVA and say, "What do you think of this desert?" And I say he thinks that he'll give me 8 more science. Brilliant! Let's board again. And finally complete our time acceleration. So we click past it, warp to next maneuver. It's only going to take 2 seconds this time to burn, so you might not even want to do 100% thrust. Now, we could try bringing back more of the spacecraft, but that is kind of dangerous because it's much more likely that things will break up. So this little blue arrow, notice how this blue arrow here, by the way, is pointing? That's pointing towards the maneuver node. So you want to get there, point at it, get your spacecraft pointed along it, And then press T again. And once we're close, we're 39 seconds out. Let's get a little closer. I'm going to get to within 1 second or so. Just throttle up the engine. We're not going to go at 100% this time. We just want to watch this and make sure that we get low enough. There we go. 34. I think we might actually... We're probably going to come down kind of slow because you notice what's happened is the planet Kerbal has rotated underneath us. So we're gonna probably... We might actually miss this desert completely and land in these mountains. Who knows? We're gonna find out! This is one of the hard parts of landing things accurately, is that you have to account for the rotation of Kerbal, and you have to account for the fact that your spacecraft is going to slow down, and you can't exactly predict its motion. Great! So I'm just gonna turn my spacecraft around backwards. And before we get too deep into the atmosphere, I'm going to ditch the rest of the spacecraft by pressing space. It's important that you do not activate the parachute high up, because the parachutes will get destroyed now. Okay, so stability control enabled. And again, time to do time acceleration. Now, and there's another set of control that I should talk about. I like to view this coming down in a different orientation. If you press V, it changes camera modes. There's free camera mode, orbital camera mode, chase camera. Chase camera is great for flying aircraft and docking, but I like this one. I like this orbit camera so you can see the spacecraft actually orienting. So I turned off my stability control and I'm naturally orienting my spacecraft into the wind. That's great. I'm seriously wondering, oh yeah, definitely not going to manage to get to the place I was hoping to land. We're probably going to end up in the ocean. Well, there you go. That's what happens when you don't think these things through. So you see that what's happening is as we're falling through the atmosphere, we're losing speed. And that means our orbit is starting to flatten out. And eventually, yeah, you see, it's coming this way. We're going to land in this ocean somewhere. We might even land in the giant crater. I doubt it. Meanwhile, we're starting to get down to the altitude where the thermal heating is kicking in. And, well, let's see how things are doing in terms of thermal heating. F12 will show you the aerodynamic forces now. F11 shows you the temperature overlay. And you can see these little green boxes showing you how hot the things are under the heat. So F10 enables and disables temperature gauges. And finally, ablator. Ablator is the substance which boils off your heat shield and protects the rest of the spacecraft. So far, everything's looking good. Everything's being kind of kept at a reasonable temperature. And you can see on the side of my nav ball that my G meter is starting to rise through about 1 G right now. So that is the force of the air just slowing us down. We're not using rocket fuel to slow down. This is entirely due to the aerodynamic forces, which is good because that means that we're not wasting resources or anything. Yeah, this is a pretty gentle descent, I think. Although our batteries are starting to heat up here. We might lose the batteries. It's starting to get super, super hot. If you're good, then there's other ways to adjust your descent so that you might perhaps keep things safe. There is a bay, a 1.25 meter hardware bay that lets you... There you go. Bingo, there go the batteries. There's a 1.25 meter bay that you can put things inside, but you have to be aware that doing that will change your aerodynamics and you could find that you're not stable. We're now slowing down at about 3 Gs. So it's actually a rather gentle descent when you consider that worst case scenario for a Soyuz abort re-entry is 20 plus G. So Jebediah Kerman having a relatively good time. Okay, so now we want to wait until we're below about 300 meters per second before we deploy the parachutes. So there the parachutes go, and those are partially deployed, slowing us down. As soon as we get much lower down, they will deploy properly. So the parachute parameters got changed a little more. These used to be a lot stronger, but now they've been nerfed back again to a little more reasonable values. There we go. Parachute opens and we land in the water. in a moment. Have I got a crew report? Yeah, we've got a crew report. We've got all the science now. We need to go to places where we haven't been. Observe mystery goo. Oh, there, that's new data. Keep that data. And how about a temperature reading? Where's our temperature? Log temperature in the water. Hey, excellent. That's a good one. Let's keep that data. We're all set. Let's recover the vessel. Our first orbit has ended in victory. Our first orbit has ended in victory. We have 106 science now. That's excellent. It means we can unlock all the other nodes. We can be proud of the various parts. We've got money. Look, we're back up to 200,000 funds. That was a very lucrative mission. And the crew has now advanced to level 1, so he gains new skills. Okay, so having attained orbit, we want to be looking further afield. We have some science, and so we're going to figure out what we're going to do with it. Now, before you go to the moon, it's really nice if you can unlock the ability to perform surface samples, and that requires unlocking the next tier of the science and research, the research and development facility. Similarly, to get to the moon, it's a good idea if to upgrade the vehicle assembly building so you can fit more parts in your designs. Right now, we only have 200,000. We can't afford to do either. So with that in mind, we're going to do some contracts to show up some new contract types and let you know how you can make a little more money. But with the science we have 106. We could either unlock one of these next tier nodes here, and there's quite a few choices, or we could unlock these two. So looking at the next tier nodes, electrics is a really good option because it gives you a probe which is really good. It has stability control and it has an inbuilt reaction wheel. And this also gets you the photovoltaic panels, and Nerd Cubed will tell you how important it is not to run out of battery power. Miniaturization gives you the Clampotron Junior docking port, so you can start building bigger spacecraft through docking. Space exploration gives you another science experiment to spam all over the surface of Kerbal. These are all really good options. But down here, there's some really useful core items. So I think I'm just going to do these two nodes because I'm going to just progress linearly across it. But it is absolutely valid to kind of aim to go down this way and concentrate on getting all the science experiments so you don't have to keep redoing them. General construction gives you the strut and the launch stability enhancer. These are both really important if you're building large rockets. Not so important early on, but all the same, I'm going to take that. And the flight control, well, this gives you your first reaction wheel, which is nice to have. It also gives you an inline cockpit, which lets you build multi-crew spacecraft, which don't look terrible. Technically, you could put multiple Mark 1 pods on top of each other, but they kind of look silly. I'm going to pick this up, even if I'm not going to use it. Okay, so with that in mind, we want to do some contracts for money. We can pick up to 7 right now, so let's pick the easy one. So, ferry a VIP. This is a tourist contract. The tourist is a crew member which doesn't do very much. Go on a suborbital flight and return safely. I think I can do that. Fly by the moon. Well, this one this one says, oh, it expires in 2 days' time. We probably want to get on that one sooner rather than later. So, science data from around Kerbal, let's accept that. Let's test our Thumper solid fuel booster. Let's take a look. Yeah, so with these contracts that are in flight, you have to test them between a certain altitude and a certain speed. And you really have to look carefully at this one. This one says you have to test a solid fuel booster. This is the next step up in the solid rocket boosters. Very powerful, very heavy. But you need to test it between 0 and 3,000 meters, which means as soon as you're flying, you're within that altitude range. However, your speed has to be 100 to 1,000. So I'm going to have to find something to boost this booster up to speed before we can test the booster. I think this is completely doable, so I'm going to accept this. Now, the radial mount parachute, this one says between 14,000 and 15,000 meters, and it has a certain speed range. This is probably doable, but you'll probably have to build a spacecraft specifically for this. If you're not traveling slow enough in this speed range, then you will not be able to do it. Radial decoupler. That's doable. We might want to think about this. The Mark 55 Thud. Now this one is saying you have to be in orbit in this altitude range. We're not going to do that just yet. Rocamax decoupler is a 2.5 meter part, so I'm not touching that. Oh wow! Test. This is the largest solid rocket booster, and they want you to take it to space and then test it. I'm not going to do that. And this one, yeah, you could do this. I think these ones you could do if you built a plane specifically to do them. You would take them up and then test them. Let's accept these, and then we'll go back and do them. So let's accept fly by the moon because we're going to do that next. Let's this turret. Yeah, okay. Test the parachute at these altitudes. Test the radial decoupler. Yes, we'll do that. And we're going to test the stack separator. So we can test all these things. These all work well. Okay, I guess we're going to pause here and actually do the mission in the next episode. Until then, I'm Scott Manley. Fly safe.